This is 8.1. We started a new unit. Hey, some of you have been coming in and finishing up that test, which is great. I usually get them graded and updated in the morning for you. So keep up the great work. And let's head to here. Draw. Yeah. I'm going to go over a couple and then if you have any questions. All right, so, yes, we will be collecting in a second. So, did I do all the way through 12 yesterday? Okay. So let's go to, did I go through 15? I didn't? Oh, I did. Okay. So go to the back side. So on these particular ones, I'm going to refer to this far board that has all the perfect squares. All right. So all right. Ready? Shh. Friends, if you do these this way, I can assure you you're going to be able to break down getting the biggest perfect square each time. So for the first one, 150 is right here, correct? All right. So what 8.1. So as we go up the list, 144 times a whole number is not going to give you 150. 121 is not going to give you 150. 100. Which one of those numbers, which one starts? 25. So 25 and 150 and 6. Cool. So notice what I'm doing. I put everything under the square root, and it's 25 times 6. 25 times 6 is indeed 150. Agree? The number in there right now that is the perfect square, the biggest perfect square, is 25. So what is the square root of 25? 5. What do I do to finish the rest of the problem? Yeah, just plug in the rest. So you have 5 root 6. Agree? Hey, 121 is pretty easy. It's one of those, right? What do you get? So that's already a perfect square. And then we go to 108. So 108 is like here. Right? Excuse me. So which number starting from 100 working backwards would multiply together to give me 108? 36? 36 times what? Times 3. Good. Okay, so again, if you using a calculator, just go backwards on it, and then you realize, oh, okay, well, 36 times 3 gives me 108. They're both still under the square root sign. So if I take the square root of 36, I get 6, and then I have square root 3. Okay? And again, I'm just kind of, I'm writing this up here. You don't have to. Just kind of do your finger. We have 60. So where does 60 fall with those numbers? 4? 4 and 15? Cool. So root 4 times 15. They're both under the square root still. Square root of 4 is 2, so I get 2 square root 15. 15 breaks down to smaller numbers, yes, 3 and 5, but none of them are those perfect squares. Then what about 27? What's this largest perfect square in 27? So I got 9 and 3. Square root of 9 is 3, so I get 3 square root 3. What about 80? 4, I love this thought. Is there anything bigger, though? 16. 16. So that's 16 times 5. So the square root of 16 is? 4. So I get 4 root 5. And notice, when I take the square root, it now comes out of the radical. Agree? What about 22? It's just 8. There's no longer a square root, correct? Because 64 is a perfect square. What about 20? 4 times 5. 4 is the perfect square. Square root of 4 is? 2, so 2 root 5. What about 90? 9 times 10. Square root of 9 is? Okay, you starting to see how these work? And then, you know, again, we still have the factor completely, so these are coming back to us. So, hey, is 25 one of the quick ways or the longer way? It could be the quick way, couldn't it? Could I just do x and x? Could I go both negative signs? What factors of 3 add up to give me -4? -1, -3. And then it's equal to 0, so solve each. Right? And you could probably skip that, the middle step right there. You can probably skip that. Okay? You just go right there. And then this one we've seen a couple like this. I could factor an x out. And so this is just going to lead me to x equals 0. This is going to lead me to x equals -9. Right? And then what about 27? Is that a special case? Is 4 a perfect square? Is x squared a perfect square? Is 25 a perfect square? Is there a subtraction sign between them? 2x plus 5 and? Good. Set each of those equal to 0. So this will be x equals -5 divided by 2. This one will be add 5 divided by 2. So you get a negative and a positive answer there. And then number 28 is one of the ones we'll have to do the longer way. So we'll multiply those together. I get +8. I know I have the same signs. They're both negative. That -9 sticks out for there. So what numbers multiply together to give me 8, add together to give me -9? -1 and -8. Okay, so you're going to plug this in to there. So I get 2x squared -1x -8x plus 4. Factor an x out of those, so I get 2x -1. Negative sign comes down. Factor a 4 out. Change the sign. So I'm going to get x -4 equals 0 and 2x -1 equals 0. So x equals add 4 to both sides. And add 1, divide by 2. Here's my two answers. All right, the last two, just going quickly through them. So that's +30. Both signs are negative. The factors of 30 that add up to -11 are going to be -5x, -6x. So that gets plugged in there.
This is a quick reminder that tomorrow students grades 9, 10, and 11 should bring your device, your school-issued device, to advisory to make sure it is ready for state testing that we have next week. So again, students grades 9, 10, and 11, please bring your student device that was issued to you by the school district. We get an advisory to make sure it's ready for state testing. And teachers, you need to get tickets from your box to your mailbox. Thank you.
You're welcome. All right, he probably couldn't hear me. Didn't say it loud enough. All right, so I did number 29 while Principal Silva was talking. This one we have positive, negative. So I think we're going to go -8x -3x. Plug it in there. Whoops, that should be a positive. So -8x plus 3x plus or -12. Factor 2x out, x -4, plus sign comes down, factor 3 out. I don't need that. All right, so there it is. Cool? All right. All right. So before I start on this, I have a question for you. This is not on the worksheet. If I did x times x, what do I get? X squared. If I did 5x times 7x, what do I get? 35x squared. Okay, so this idea is going to play along with what we start on today, but let's warm up with the first 8. All right. So, problem number 1, what's the answer? Just 6. It's already a perfect square. It's a part of our perfect squares on the far board. What about number 2? 11. It's one of our perfect squares right over there. What about 3? What about 4? Then 5, we have to start breaking them up, right? All right, so what times what? What's the biggest perfect square using that, starting from the bottom? What breaks up to be 98? 49? Yes, it is. 49 times 2. 49 is the perfect square, yes? So I get 7 square root 2. All right. What about 40? What does that break up to? 4 and 10. Good. 4 is the biggest perfect square. Square root of 4 is 2. So I get 2 square root 10. Then we get to 180, which is beyond our list. What two numbers? Using one of those blue ones would give me the 180. 36 times 5. Really? Is that right? Benito, we're waiting on you. Say maybe that's right. Yeah, 36 times 5. Very good. So calculator definitely help you on that. So a lot of people might have said, well, 9 would work. You're absolutely right. And 4 would work. You're absolutely right. Well, what's 9 times 4? 36. That's why 36 works. So square root of 36 is? Good. So 6 square root 5. And then 54? 9 and 6. Cool. So square root of 9 is? 3. So 3 square root 6. So that was yesterday's. Agree? We've been doing that yesterday. So remember what I had shown you just prior to us doing this? We could multiply two things together. Okay? So let's look down here. So first thing I want to just kind of put off to the side. If I had 5 square root 2, if I say 5 is outside, does that make sense? If I said 2 was inside, does that make sense? Okay? So we're good with outside and inside on these problems? Make sense? All right, so number 9. I'm going to multiply the outsides first. So 3 times 5 is what? 15. Then I'm going to multiply the insides together, and I'm going to get 14. Hey, I have a question. We're not done yet. Well, we might be. Is 14, will 14 break down to any of those blue numbers on the board? Any of the perfect squares? So this answer is done. Okay? All right, so I multiplied the outside and the inside, and then I had to break down the radical if I could. So number 10, let's multiply the outside. So the outsides multiplied give me 18. Multiply the insides, I get what? 16. What's special about root 16 over there? Yeah, what's the square root of 16? 4. So I'm going to go 18 times 4. And 18 times 4 is? Anyone got an 18 times 4? How much? Close. 10 off. Or 8 off. It's 72? Oh, it is? Oh, can't take me anywhere. That's right. Hey, where did the square root signs go? Well, the square root went away right there, right? So 72's answer is no square root. That's done. So the square root sometimes will go away. Sometimes it'll stay in there. All right, number 11. Multiply the outsides, I just get 5. Multiply the inside, what do I get? 12. The reason I get a 5 for that is there's really a 1 out in front of that. Can I break 12 down into any of those? 3 and 4, right? 4 is the perfect square. What's the square root of 4? 2. So this becomes 5 times 2 root 3. 5 and 2 are both outside, so I do what? Multiply them. 10 root 3. Oh, now we incorporate a negative. Outsides multiply gives me what? Negative 30. Do you feel comfortable with that? And then 6 times 12. 6 times 12. 72? Is that right? Cool. Will 72 break down? Because 72 is still inside. Can I break it down? Look where 72 would fall on that list. So 64 won't work. 8 and 9, I like this. Is there anything bigger than 9? Yes, 36. The reason we didn't do what 8 and 9 is I want the biggest perfect square. 36 is the biggest perfect square. Hey, what's the square root of 36? 6. So I get this. And I get that. The negative 30 and the 6 are both outside, so what do? Multiply them. That's how it works. Seem to make sense so far? Digesting it okay? Hey, is my attendance right? No. Uh-oh. All right. Can I move to number 13? Is that okay? Sean, you good? It's root 49. I like this, Jeffrey. So inside's root 49. And what's root 49? Notice the square root went away. I just get that. So sometimes you can multiply two radicals together, and that happens to come out to a perfect square, which is good. And then you just take the square root. Okay, so I have a 1 out front, so what's my outsides? I'm 14. 5, and then inside? 60. Okay, take a look at our blue chart. So does 49 work? No. Does 36 work? No. Does 25 work? Does 16 work? See if 16 works. I don't know. If that doesn't work, what else might work up there in the blue? 4 and 15. Good. Square root of 4 is what? 2. So I get 5 times 2, root 15. The 5 and 2 are both outside, so what do? Multiply them. There it is. Okay, fist to 5 on these. We haven't done fist to 5 this semester. 5s, 4s, 5s. Fist to 5s, 4s, 4s. 3. 2. Where can I help you? Just the very last one. Okay, so 9 through 14.
Oh, I just had a question.
Yes.
How do we get from 5 to 15 to 5 times 2?
Cool, great question. All right. So first thing I'm going to do is I'll have this. We'll always have this up. Test quizzes is always going to be up. Perfect squares. Okay. So what I'm going to do is I look underneath the square root sign and say, okay, 60 would fall. Well, we already have 60 right there. So will 49 times something give me 60? No. Will 36 times something? No. Will 25 times something give me 60? No. Will 16? No. Will 9? No. Oh, 4 and 15 would work. So I'm looking for what's underneath the house to see if I can break it up and find a perfect square. And the perfect squares, that's the key to come outside. Okay? So when we did this, we broke this down to this. We found that this is a perfect square. So the square root of 4 gives me 2. So it's no longer underneath. And then when it becomes outside, anything else outside gets multiplied. Okay? Did you guys ever play, I'm going to get the game wrong. It was a hide and seek game. Okay, so how did sardines work? One person would hide, and then as you find that person, you all hide with them. Okay? This might be a bad analogy. Okay, so like sardines. One person hides, and say there's 10 people total. One person hides, so 9 people are looking for the one person. And as you find that one person, you all sit there and start hiding. And then the last person is out. The next hider. Yeah, so those games of hide and go seek. Those are good games. I like those. What was the one that we used to call it? Did you guys ever play the one called Ghosts in the Graveyard?
Oh my god.
Which one was that one?
It was like when you had your bug outside.
Uh-huh.
And you were learning how to see.
But you have a flashlight.
Yeah, but like I thought it was something else happened.
There's all kinds of modifications of a hide and seek situation. I'm almost done. Can you hold off for 3 questions? Cool. All right. Let's go down to number 15. Let's go down to number 15. All right. So inside is 232. Okay. So is it 232? 242. 242. All right. So 242. We haven't had a number this big yet. But let's see if we can make it work. All right. 242 is like down here on the list, right? I mean, the more things on this list is 169, 196, 225. All right. So starting at 144. Can I multiply 144 times a whole number to get 242? No. Can I multiply 121 times a number to get? Yeah. What do I do? 121 times 2. Cool. So 121, that's the biggest perfect square that's going to work. So this is going to be 121 times 2. So what's the square root of 121? 11. What's left behind? Root 2. Woo. Woo. So square root of 121 is 11 times 11. So you take the square root of 121, you get 11. Okay. Let's look at number 6. Outsides. What do I get outside? 8. What do I get inside? 72. Okay, we've done 72 a couple times. What's that going to break up to? 36 and 2. I like it. Hey, what's the square root of 36? 6. What's outside? What 8 times 6 is? 48. Cool. That's done. 48 root 2. All right, I got a 1 out in front of here. So what's outside? 3. What's inside? 48. We've done 48 before, haven't we? Okay, careful on 48 because a lot of people want to go right to 4, but what's bigger than that works? 16. So 16 times 3, right? Agree? Square root of 16. What's outside now? 3 times 4, which is 12. That's it. All right, fist of 5. Now we haven't done fist of 5 for about 4 minutes. Okay, I'm seeing some better looking numbers. You feeling comfortable? Okay, hey, I'm going to give you the opportunity to start on the back. Give it an honest try. Okay? Actually, go to number 19 real quick for me. Yeah. Hey, go to number 19, though, real quick. Take a look here. If I multiply insides, what do I get? X squared. Friends, does anyone want to know what the square root of x squared is? What's the square root of x squared? Just x. Okay? So a letter can be a perfect square if raised to an even number. Even numbers are like 2, 4, 6, 8. Those are even numbers, right? So if you do the square root of a letter, and it's, so if I had, say this, I know this is not a problem I was given. If I had this, that is a perfect square because it becomes x to the 4th. Okay? Notice I didn't have to look on my list. I just had to take half of the exponent to take the square root. Okay. So try the rest. You have some time to work on it. Okay? Ask me. I'm happy to help you. Notice the last 4 are still the factoring. So, if you're still struggling with factoring, come see me. Let's work through it right now during class as well. And, go with that. Cool? Everyone good? Everyone happy?